each median have the ratio 2:1 with respect to centroid. We have a one right angle triangle, let's say, kind of like in this way. Now in this right angle triangle, first read carefully. There definitely you have a logic. Hello everyone, welcome back to Alan Overseas. Let's continue our special series. In this series, we will cover 45 important topics in 45 days, which will really helpful to all JEE Mains aspirant. And the topic distributions are 15 physics, 15 chemistry, and 15 maths. I am going to cover math section here. This is the study challenge we will cover in this series. And our today's topic is different centers of a triangle, which is under the chapter straight line. You can see there is a lot of previous year question on the basis of this topic only. So without wasting too much time, let's start. So the first one we have centroid. So the centroid is what? The point of intersection of the medians. And trust me, this is more than enough definition to understand this one. What? Point of intersection of the medians. Medians is what? Line joining the midpoint of sides and opposite vertices is called centroid. So how we can find the coordinates? It is quite easy. If you have one triangle that is something like ABC, and here the vertices also you have x1, y1, x2, y2, x3, y3. This is your medians AD, BE and CF. Now the intersection of these all medians, you will get the centroid, the very first thing. Now, what about coordinates? Coordinates is simple. You can find with arithmetic mean of x coordinate, you will get x coordinate of centroid. Similarly, arithmetic mean of y coordinate, you will get the y coordinate of centroid. Now, the next one of the most important one in the centroid is the median cuts, centroid cuts the median like into ratio 1. This is also important one, right? So each median have the ratio 2:1 with respect to centroid. Now the next one is incenter. Again, the incenter is what? The incenter is the point of internal bisector of the angles of a triangle. So again, this is more than enough to understand the definition. The incenter is the point of internal bisector of the angles of a triangle. Again, let's say you have a one triangle which is something like in this way. Now, the internal angle bisector, that means the internal angle of A we have like in this way, AD. Similarly, internal angle bisector as well as, right? This is bisector. This one is also bisector. Similarly, the bisector from C you can make. Now, the intersection of these all will known as incenter, quite easy. Again, sir, how we can learn the coordinates of incenter? Again, it is quite easy. Why I am telling you this thing? Because there are the symmetry I am able to see there in the formula. For the x coordinate, I am going to talk about only for x. That is how ax1 plus bx2 plus cx3 upon a plus b plus c. Similarly for y, ay1 plus by2 plus cy3 upon a plus b plus c. Now the question is, sir, what is ABC? In SOT, we also have proved this thing. Even also you can prove this thing. I don't have any problem. But usually I recommend you to understand and learn this formula directly because they are easy to learn. And JEE will not ask you to prove this one. But although you can see the A, small a, is front of angle A, usually we have denoted as small a. Such kind of work we did in SOT, solution of triangle, right? Front of angle B, we have B length, and front of angle C, we have C length. So small a, small b, small c, kind of like in this way. Now it is quite easy to remember this formula, that is ax1 plus bx2 plus cx3 upon a plus b plus c. And similarly for y. If you make a one circle which is touching all the bisectors and that is like E, F, D, you will get a one incircle with respect to incenter, whereas the radius is like from I to E for this incircle. Similarly, F to I as well as I to D. That would be your in-circle radius. Usually we known as in radius. Quite easy to learn. But yes, this is more than enough to understand how we can find the coordinates of in-center. Quite easy. Now the next one is again interesting one, that is circumcenter. So let's see the definition part. It is the point of intersection of perpendicular bisector. Again, this is more than enough to understand the complete circumcenter, especially the definition part. The point of intersection of perpendicular bisector. Perpendicular as well as bisector. So how we can visualize this thing? That's why I am here. See here. Let's say I have a one triangle that is something like in this way, A, B and C. Now I am going to make a one perpendicular bisector on BC, that is like in this way you can make. Similarly from C you can make, from B also you can make like this. Now this is your perpendicular as well as bisector. Perpendicular as well as bisector. Perpendicular as well as bisector. You know, the intersection of these all perpendicular bisector will known as circumcenter, and I am going to denote it as O. Now, sir, how to find this circumcenter? Important one. So my dear student, if you understood the definition, then you can find easily. There is no big task. How? I am telling you the process. Listen me. You have the vertices of ABC. Initially you have the vertices of ABC, that is like x1 y1, x2 y2 and x3 y3. Now you have the slope of AB. Let it be, you have the slope of AB because you have 2 points. You can find the slope of AB. Now actually C to this one, let's say this is M. C to M is a perpendicular as well as bisector. So there are different way to generate the equation of CM. How? The coordinates of M you can find it very easily because this is the bisector as well. Apart from this, you can also find the slope of CM. How? The slope of CM is -1 upon slope of AB because both are perpendicular, right? So once you have a slope and you have a coordinates or you have a point, then no one can restrict you to design the equation of line. It is quite easy task. Point slope form you can apply there. Similarly, from B again you can, let's say this one is N. From Bn I want to design the equation of line. Again you can make, this is quite easy. How? This is perpendicular on AC. You have the slope of AC, that means indirectly you have the slope of Bn. How? -1 upon slope of AC. Once you have the slope, you have the point, you can again design the equation of line. Once you have the equation of Bn, equation of Cm, so solve these two equations and find the value of x and y. You have the coordinates of O. There is no need to design the equation of this one bisector. Quite easy task. Now the next thing, as in the previous one we have in circle with respect to in center. Now we have circumcenter, that means we can also make a one circumcircle. How? Circumcircle like in this way. In this circumcircle, you can visualize here from O to A is what? O to A is the radius, O to C is also the radius, O to B is also the radius. That's why I am telling you, in this circumcenter, in the triangle, OA square, OB square and OC square all are same. It is quite easy to understand. Now apart from this, I have one more thing for you, in which you have previous year question. That is what? That is the case of right angle triangle. Sir, what happened if you have right angle triangle? Listen me well. Let's say I have one right angle triangle that is like in this way, A, B and C. Now here I am going to make a one perpendicular bisector on the side BC as well AC. This is perpendicular as well as bisector. Perpendicular as well as bisector. Now you know, according to the concept of circumcenter, according to the definition of circumcenter, the point of intersection of perpendicular bisector is known as circumcenter. That means the circumcenter now in case of the right angle triangle is here, and you know that would be the midpoint of AB according to the definition, because this is the perpendicular bisector on each sides of the triangle. So that's why now the circumcenter in case of right angle triangle you can find it is the midpoint of hypotenuse. Always remember this sentence. Quite easy to understand. Now in the next one we have also it is the center of a circle passing through the vertices of a triangle, as we have discussed the center of a circle which is passing through the vertices of the triangle. Now the next one is orthocenter. In this orthocenter we have it is the point of intersection of the perpendicular drawn from the vertices on opposite sides, or the synonym is altitude. Quite easy to understand. How you can make an altitude from A, from B, from C. Intersection of your altitude will be known as orthocenter. Quite easy to understand and the simple task. But again the main question is, sir, how to find the coordinates of orthocenter? The answer is simple. You can find again while solving the equation of altitudes. Why I am telling you this thing? You know, this is altitude. The such kind of the work which we have did in circumcenter you can again proceed in orthocenter. The altitude you have, actually the slope of BC already you have. I don't think so anyone will get any problem to find the slope of this line A. The slope of A would be the -1 upon slope of BC, because both are perpendicular. That means once you have a coordinate, once you have a slope, again you can design the equation of altitude. Same process you can proceed with BF as well as CD. You can solve these two equations and you can find the coordinates of orthocenter. Quite easy to understand. Now, the one important note in this, if a triangle is right angle triangle, then orthocenter is the point where the right angle is formed. How? Let's visualize this thing. We have a one right angle triangle, let's say, kind of like in this way. Now in this right angle triangle, you know, according to the definition part, the intersection of altitudes from the vertices. Intersection of altitudes from the vertices, from A, I am going to make a one altitude which is actually by default this one itself, AC. From B, actually by default this is itself BC. So the intersection of these two according to the definition is orthocenter. That means this one itself would be the orthocenter. Quite easy to understand. In coordinate geometry, the only thing is matter to visualize. Once draw by yourself, visualize the things, trust me, you will get. Now, the next one, first one remark that you need to remember, if the triangle is equilateral, then the centroid, incenter, orthocenter, circumcenter, all are coincide. How? Again, you can see there. For example, you have a one triangle that is something like in this way. And this is equilateral triangle, you know. Equilateral triangle, that means all sides are same, all angles also must be same, that is 60 degree. Now, you know, if we make a one perpendicular, so actually it will definitely bisect the angle as well as perpendicular, and according to the definition, basic definition of the triangle, it will definitely bisect as well. Similarly, from C you can proceed same kind of the work. So in short, in this entire triangle, actually we made only one thing, that is internal angle bisector. But by default, it will make himself perpendicular as well as bisector. That's why all the things, that means intersection of these all, you will get here centroid as well as circumcenter as well as orthocenter as well as incenter, right? So centroid, incenter, orthocenter and circumcenter, all four are coincide here. And the next one, orthocenter, centroid, circumcenter are always collinear, and centroid divides the line joining the orthocenter and circumcenter in the ratio 2:1. See, again you can visualize this thing. Let's say here is kind of the scenario, HGO. While taking the vertices also you can prove this thing, but again I recommend you to remember directly as a property, right? So this G will divide in the ratio 2:1. This is the property. HGO is the series, you have to maintain the sequence HGO, and this G will divide in 2:1. So this is the concept part, which is important one. All the four things we have covered. First one is centroid, incenter, second one, third one is circumcenter, and the fourth one is orthocenter. Now it's time to do a 1P by Q on the basis of these all, which is from 2023. And the question is, let's see alpha comma beta with the circumcenter of the triangle formed by the lines. The one line we have this one, second line we have this one, and next one is x plus 7y is equal to 61. Now we need to find alpha minus beta whole square. That means alpha minus beta, this expression we need to find. The first thing which I am able to see in this question, that is what? And also in the exam, if you will get a question, then always remember my word. First, read carefully. There definitely you have a logic behalf of the equations. If you observe well, you can pick that one. So in this question, first of all, I am going to pick this one line, that is 4x plus 3y is equal to 69. And the second line, in second line I am going to multiply with the negative sign. Then I have 3x minus 4y is equal to minus 70. This one is equation number 1, this one is equation number 2, I am going to mark. In equation number 1, the slope of this one, we have minus 4 upon 3. Similarly, the slope of this line, we have 3 upon 4. Now, if I am just going to make the product between of M1 and M2, we are getting very interesting thing. That is what? 3 by 4, we are getting minus 1. And actually, M1 and M2, if they are minus 1, that means both the lines are perpendicular. That means now I can make one beautiful diagram to depict this given data, in which we have what? Like for example, these two lines must be are the perpendicular, and these two lines I am going to mark as like 4x plus 3y is equal to 69, 4x plus 3y 69, and this one is like 3x minus 4y minus 70. Now the next one, another one line is there, which is like x plus 7y is equal to 61. They are making the triangle, so I have to make this line like in this way. So let's say this is your x plus 7y is equal to 61. This one I am going to write as equation number 1, this one as equation number 2, and this one as equation number 3. Now here these two lines are perpendicular, that's why I have made it like in this way. These two are perpendicular, so there is perpendicular. Now after this, according to the concept, first of all we have to understand the concept. The concept is simple. The circumcenter in the right angle triangle is the midpoint of hypotenuse. So that means this is hypotenuse. So here I try to find the coordinates of this and this. Let's say this is something like A and B. So how to find the coordinates of A and how to find the coordinate of B? Simple task. We can find easily. This A is the intersection of this yellow as well as this green. That means intersection of 2 and 3. So let's start. The intersection of 2 and 3, that means equation number 2 from equation number 2 and 3. What I am going to do? In equation number 2, I try to cancel the x. So that means I am going to multiply with the x. So here you will get, in equation number 3, I am going to multiply here 3x, 21y, and then minus 183, 0. And there is also 3x minus 4y. 3x minus 4y plus 17, 0. You can subtract these two, negative, positive, negative, and then that would be cancelled. 21, 4, 25y. This one is minus 200, you can write is equal to 200. You know, after solving this, you will get y as a 8. Once you put y is equal to 8 here or there, you can put anywhere. I am going to put here. So you will get 56, 61 minus 56, you will get 5. So x, you will get 5. So now congratulations, you have the coordinates of A, that is 5, 8. Now same kind of the things I want to proceed for B. For B, this is the intersection of this green and this yellow. So that means intersection of 1 and 3. So again I am going to solve equation number 1 and 3. Equation number 1 and 3 I am going to solve here. Again here I am going to cancel x, so that's why I am going to multiply with the 4 in equation number 3. Then I will get 4x, 28y, 244 is equal to 0. There is 4x plus 3y minus 69 is equal to 0. You can subtract these two. So there you will get, this one is cancelled. There you again you have 25y, and now you have 175. Now 175. So you have y, that would be what? 7. Once you have y is equal to 7, you can put anywhere, either in here or in here. Again I am going to put here. So 49 is there. So x you will get 61 minus 49. So that would be 12. Again you have the coordinate of B, that is 12, 7. Now as we all know, there is the circumcenter is what? Circumcenter is this one. This is your circumcenter. You can find, because this is the midpoint of this one. So the midpoint of this circumcenter, you will get 12 plus 5, 17 upon 2, and 7 plus 8, you will get 15 upon 2. So in short, according to the question, you can treat this value as alpha and this value as beta. You have alpha, that is 17 by 2, you have beta, that is 15 by 2. Now see actually what they are asking. They are asking alpha minus beta whole square. Okay, no problem. So we can proceed. Minus beta, we have 15 upon 2 whole square plus alpha plus beta 17 upon 2 plus 15 upon 2. Now 17 minus 15, again 2 upon 2, that would be a 1, and there is 32 upon 2, you will get 16. So 16 plus 17 would be the final answer. That means option B would be the right answer of this question. Hope it is clear to everyone. And that's all from my side on this topic. Don't forget to watch the complete series. The link is available in description box. Still, if you have any query or any suggestion, feel free to reach out to us through the comment section. Thank you.